Hello and welcome back. Today I have a frequency counter, and if you are a fan of frequency counters, today you are in for a treat because I have here it's the Racal 1992, the 1992, and if you are a fan, you probably have seen one, you've been looking for one, or you maybe even have one. Well, I have one here. This is one also with the C channel, and I think it goes to 1.3 gigahertz. So let's find out and have a closer look. From the front, look at the design. It's very distinctive for this brand. Most of their meters in this series looks like this, and somehow it just catches my eye. And well, it says here it's the nanosecond universal counter. It has an A, B, and a C input. The two inputs here go, I'm not sure, probably up to 100 or 50 megahertz, and then you have the C input that goes a lot higher. Well, usually it's written on the front, but I can't really see it, so we can have a look in the manual. Well, the casing looks still very good. I was lucky with this find. Even in the back here we can see that the seal has been opened, but this calibration sticker has not. Well, we're probably gonna calibrate it again. The setting is already to 240 volts. Always check first, and I prefer it to 240 than to 230 because with all the solar panels we are slowly going higher and higher here. So here are two things missing and a little bump here. That's it. All the feet are still there. It even has the standstill. So let's power it up. I had a quick look at the specifications, and 1991 can go up to 160 megahertz on both channels, while the 1992 has also the third channel, which can go from 30 all the way up to 1300 megahertz. And I kind of forgot, because I bought it a few months ago, what type of option there is, because you have different accuracies of the internal oscillator. So I have here the option list, and I need to look back a little bit in my papers what options I have. Okay, this one does not have the improved oscillator. At least it was not mentioned by the seller at that time that I bought it. I think I was confused with buying 1998, and I have a 1999 as well. And there we can maybe see the difference between those oscillators. So it's a default standard oscillator, or it is there, and then, well, we can have a look. I'm looking here at the back, and if the option was officially, then they probably would have said here if it was a 04A or 04B or 04T. And well, the list is empty, but it still doesn't mean that that aftermarket could have put one in with. So let's just see if it works. Plug it in. It's completely cold, so it will not be very accurate. 1992, and that's it. It boosts very fast. It doesn't mention any options, but I'm not sure. I'm not that familiar with this counter. Let's put channel A. Well, let's have a closer look on the controls first. It seems all very straightforward, to be honest. Here you can make your selection with these two buttons, the channel A, period channel A. This, I think you compare the A and the B, total A and B, phase shift A and B. The check, it's compared with this internal, of course that is always exactly 10 because it compares with himself. Ratio A and B, even a ratio C and B. But let's go to the frequency A. Here we have, it is now set to a resolution, so you can add or remove zeros. Well, we like a lot of them. There is an hold button. I'm not sure what you can do with this, but you can set an auto trigger levels, DC, even 50 ohms. Let's put 50 ohms, attenuators and filters. Let's just do auto trigger 50 ohms. When I pre-announced this on my community tab on YouTube, I made a picture and said, look what I found, all excited. And a few people said, yeah, you need to be careful if you buy these counters because your buttons can be broken because they seem to lose contact after a while. That's just how it is designed. But if you have the later models, I think that is better. If you like to see how to repair that, I think DevCon did a few videos about that. But let's see how this works. How accurate is it? It has not been on very long. Yeah, the internal runs a little bit faster, and that's why we get a lower value. Of course, if you take out a few digits. Okay, we need to adjust that. I think there was also a video from Dave, and it has to do with gravity, especially with the standard oscillator. If you put it on its side, it will change. Here, it goes already. So if you need to adjust it, you need to try to put it in the same position and it will recover again. Or it's just now the temperature. That could also be the case. I will just leave it running for a while. Well, I opened it while it was running, and well, of course, by opening it gets better cooling and then it will change again. So I think adjusting will be done when it is closed exactly in the position that I'm going to use it. So we just have a look inside. That actually looks very good. Not testy. It seems super clean actually. It is tested in 1985. Well, I will take this is the GPIB board, I think. Yeah, let's try to get that out and then we can have a better look. Oscillator here in the back. Let's see if it says what type it is. So we find out if it's the original or an improved. And oh yeah, here we can have to look later better. The prescaler right there. Yep. Holbert and GPIB is version number 4.2. I'm not sure if that is new or old, but it is this version. Let me see if I can put it safely somehow. Yep. Let's have a look at the oscillator. Well, I think the GPIB board is also an option, and it was not on the back, so it still could be that they did more improvement. Well, of course, power supply cap looks still good. This one seems a bit bull. Maybe it needs to be replaced, but it is still working fine. And let's turn around. So I turn it around, then we need to open it like this. And well, here it's a lot of the time they do this pre-scalers. They put just on its side, and this goes directly to the channel C. And yeah, it's just a divider. Yeah, the nice thing of the pre-scaler is that you can measure a lot higher frequencies, and we can see that also in this frequency counter, that on the channel A and B it can go to 160, while on the other channel it can actually go to 1300 megahertz. So let's say it's sort of a divider. It divides by 10. It lets the counter know that it is actually measuring 10 higher, so it will just multiply the value on the screen. But what it's actually measuring is a lot lower. Only downside of having a prescaler that if you have a special frequency counter that can measure also peak to peak or power, then of course you lose that usually on your C channel on the prescaler channel. Now I'm interested in the oscillator that is right there in the back, because you can adjust it from here. So I think I'm gonna take it out and then we have a closer look. I just took the GPIB board out to have more space, and it looks like it's only one screw, and then it is the connector. So, very long screw, and yeah, that seems to be it. I can just pull it out. When I look at this board and the pictures, this is the standard oscillator. Because if you have the option 04T, that is the second one, that looks like this. Yeah, you can see that the oscillator block is a lot bigger. So this is the standard one. This being the standard oscillator, you can maybe improve it just by putting one of these, or if you want to make it even better, one of these. And if you're lazy, you just buy these modules. You can buy it between $10–15, I think, and then you can run it a lot more stable. I'm not going to do this. We will just adjust it as good as possible, and later I will just run it on external reference. I put it back together again. I'm not going to do much about the oscillator because it is just a standard one and should be able to adjust it reasonably good, and it's going to run on external reference also. Because it was open, I found this very old capacitor. Usually I don't replace them, but this one looked like it came from my grandpa's radio, so I couldn't resist to do it. Also, I cleaned the back. I took the calibration sticker completely out, because when you break the seal of the calibration sticker, it looks like, oh, somebody messed with the calibration. But if you just remove it completely, then yeah, no, it doesn't stand out too much. So I'm just gonna let it heat a bit more, and then we're going to adjust it. And then we check the limit of the C channel. Can it indeed go to 1300 megahertz? Well, maybe also interesting to see. This is my external reference, exactly 10 megahertz. It is here a little bit low, and I mentioned, yeah, that's probably because the oscillator inside is too high. And when that is too high, the period becomes smaller, and then it has less time to count, so it means we will see a lower value. So, but there is an external reference in, but there is also an external reference out. So maybe we can tap into the reference out. I can show it there on the frequency counter, and then we should see that it is higher. So let's have a look at it. Well, and here we have it. You can see it's running a little bit high, and exactly what is here to high is here to low. 45, 645, 355. And you will see that change. I have one digit less. So let's see, like this. Or I add the digit in. And I add the digit here. Three, 4, 5, 3, 3, 4, 5, 7. Exact difference. So if this sort of stabilized, then we can adjust the oscillator. Looking what comes out instead of looking what is on the display is also a very nice trick, because if we look at it like this, because I need to adjust in the back, I can put the legs down, so then I need to adjust here, and then I will not be able to see the display, or I can have a look at with a mirror, but I can also just look what comes out. So that's what I'm going to do now. Just also, if you adjust, don't use a normal screwdriver with metal, because that will interfere with the oscillator. So I'm using this ceramics one, and well, I need to find a little bit where it is, and then we can just have a look there. Well, first I wanted fast response, so I do one digit less here, and then it will respond a lot faster. And then we just slowly start adjusting. Oh, almost there. Oh, it's sensitive. A little bit more. So now the oscillator is slower. It means it will count more. And indeed it does. If we go here one less. It counts now too much. Okay, well, this is the best I can do. I'm now within 1 hertz. Here, half an hertz. So this one will be a half one too low. 1, 2, 3, 1, 2, 3 below. Or instead of a little bit above, I do it now a little bit below, because it just looks better in the display. So this is 1, 2, 3, 1, 2, 3. This is below the hertz. 0.1 hertz. It's off. Well, 15, I would say. But if we want it spot on, you're just going to use the external reference. Yeah, the standard crystal oscillator will of course be sensitive for temperature a lot more than the temperature controlled one. So it will go a little bit up, go a little bit down. Probably if I put my hand, it will be influenced a little bit. So if we want it really spot on, then we need to use the external reference. So I'll get another cable, and well, I can use this one. I need to be sure I'm not taking the trigger port. So which one I do? External arm, not external in. So you see, if I'm moving it will make a change. So what if I now put in, puff, spot on, and the light external ref is there. Yeah, this is of course great, because this will be the same actually now as if I would do the test, because you're just comparing it to the same. And of course the time period will be exactly spot on as well. Let's see the limits. Okay, I have here my little WB-HG1 from BG7 TBL. It is putting now 50 megahertz, and I think we should be able to go up to 160. Also on external reference, as you can see, because it is spot on. And you will find a little difference if I take the reference out. and we glue more. $160. Can we do a little bit more? Can I do an extra digit? Yes. Can we go a bit higher? No. Okay. Yeah, sensitivity will go down a little bit. 180. 190. 200. Okay, still going. No. Oh yeah, there it is. No. So it can do, but of course with less sensitivity it can do up to 200 instead of the 160. I also have the bigger brother, the SG2, a little bit nicer now to see. Also connected to external reference. Oh, I see the frequency is still a little bit high. Let's drop that a bit. 300. And now we will be using the, I do 0 dB to the C channel. C channel. Here we go, 300. We should be able to go a lot faster. The gate stays the same. 400, 500. And we go more and more. And this is what he should be doing. And can we do a bit more? Yes, it can. Oh, look at that. No, that's the limit. 1.6 gigahertz, not bad. So that was the Racal 1992, and we have adjusted the oscillator. Pity it was the standard one, but running it now on external reference, you don't feel anything of that. And yeah, we were able to test it up to 1600 megahertz, while it was only rated for 1300. But keep in mind, it's not a fair test. You only test the limit of all the electronics, not necessarily of the analog circuit in front, because we do it with a lot more. A fair test would be around 50 millivolts, but I'm just like to see how high it goes, as I usually did. Thank you for watching, and hope to see you next time.